Hi again, George is with Crystal Cove Conservancy. I'm going to talk to you all a little bit about Google Sheets first. Google Sheets is like Excel. It is a great tool for visualizing data. To learn a little bit more about Google Sheets and how we'll be using it to analyze data, let's try and analyze this first question. Our first research question is, what type of plants will decompose the quickest and which will decompose the slowest? Water saver plants, water spender plants, or non-native plants? To answer all of these questions, we'll be using this table below. This table has a lot of different sections, and I'll be going over them. First, we start with bag number. Bag number is just a combination of letters and numbers to identify the bag. Next, it's bag type. Bag type just talks about the type of leaf litter that is in the bag, and we have 3 different types of leaf litter: water savers, water spenders, and non-native leaf litter. Next, we look at plot type. Plot type represents the type of plot in which the bags were dropped in. And it also has 3 categories: water saver plots, non-native plots, and water spender plots. Next, we'll look at initial mass. Initial mass just talks about the mass of the bags when they were first made. Final mass is the mass of the bags as you weighed them during Project Crystal Code. And lastly, we have percent mass loss. Percent mass loss shows the percentage of the leaf litter that has been decomposed. Percent mass loss merely shows the percentage of decomposition that has happened. If the number is higher, that means more decomposition has happened. And if the number is lower, it means less decomposition has happened. An example is, our bag AA2 had 7.55% mass loss, whereas our bag AA1 only had 2.44%. So we can say that more decomposition has happened in bag AA2 than in AA1, because bag AA2 has seen 7.55% of its matter decompose, whereas bag AA1 has only seen 2.44% of its mass decompose. We'll also be looking at a few different questions. The next question we'll be looking at has to do with the restoration effects of decomposition. And that question asks, where will leaf litter decompose the quickest and where will it decompose the slowest? In areas that are restored or in areas that are unrestored? And again, we see our table. We see the familiar bag number. Plot type is seen again, but this time it is divided between restored, which is our water saver plots, and unrestored, which is our non-native plots. Bag type again is differentiated between water saver and non-native. We also see percent mass loss. Our last question asks, where will soil moisture be the highest and where will be the lowest? In areas with water saver plants, water spender plants, or non-native? And again, our table shows us plot number, which is the number of the plot where the bags were retrieved from. Plant type talks about the different type of plants that are being measured. And this is also divided in 3 sections: water saver, water spender, and non-native. And lastly, we have soil moisture percentage, which looks at the percentage of moisture in the soil. Returning to our question number 1, we're going to be comparing the percent mass loss for all 3 of our bag types. And these would be water saver, water spender, and non-native. As you can see, each bag type has very different percent mass loss. So how can we use one number to represent all of these numbers? Get together with your team and brainstorm.